So welcome today to today's webinar, where we're going to explore the future of enterprise data science and go into details around Domino 4.2 and the capabilities that we introduced a couple of weeks ago. My name is Bob Laurent, and I run the product marketing team here at Domino. And I'll be joined by two of my colleagues. Yorgi, would you like to introduce yourself?
Thanks, Bob. I'm Yorgi Matev. I'm one of the product leads here at Domino. I hold a broad view of our product and kind of cover it architecturally, as well as focus on particular elements of our platform.
Cool. How about you, Austin?
Thanks, Bob. Hi, I'm Austin Ford. I am one of the product managers on the team. I focus on the data science workbench as part of Domino, specifically thinking about how to best support data scientists developing data science products.
Cool. As I mentioned, I'm Bob Laurent. I run our product marketing team. So in terms of today's agenda, what I'll do is I'll start with a brief introduction to Domino. I'll just go over the basics of who we are, what we do, the problems that we solve. We'll spend the majority of our time today going over the new capabilities that we introduced in our 4.2 release, as I said a couple of weeks ago, that are really, powering the future of data science. And then we'll have time at the end for questions. So there's a Q&A box at the bottom of your screen. Go ahead and submit your questions in that box, and we'll definitely make sure that we find time to answer as many as we can at the end of the webinar. If you have any sort of administration or administrative questions or concerns, go ahead and put them in that box as well. We've got a team of people who are monitoring that right now who can get you any answers that you need during the webinar. Okay. So a little bit about who Domino is. We've been around for about 7 years. We created the modern data science platform category. Since then, we've become the real data science system of record for the enterprise. And we were really fortunate to be trusted by 20% of the Fortune 100, including some of the largest banks, health insurers, pharma companies. We're fortunate to have many of the companies that you see there on the right side of the screen as our customer. We've been in the Forrester Wave in the upper right-hand corner as a leader on their notebook-based ML solutions. And we've got, at this point, 160 employees and growing very quickly across the world. Our headquarters is in San Francisco, but we have offices in New York, Chicago, and many other places around the world. So when we think about the problem, I'm sure many of you can relate to the fact that you'll have different pockets of people building data science in the enterprise. You might have one group who is successful building a model. They may even be able to get it deployed. But when they think about how do we scale data science across a growing department or even their entire company, they find that it's very challenging. They run into a number of different roadblocks. And in the 7 years that we've been doing this, there are 3 main themes that really come up over and over again. The first is around infrastructure friction. And this is being able to provide data science teams access to reliable compute resources so that they can do their experimentation. And really taking into account some of the breakthroughs that are happening in cloud computing and being able to roll that together to do effective research. They also want to take advantage of all of the innovation that's happening in the open source community, be able to download and use all the latest tools that are coming out, which fundamentally is at odds with many IT organizations who are trying to lock it down and really enforce strict governance and security guidelines, which at the end of the day really slows down innovation. The second thing is the lack of knowledge management. And every time a data science team starts a new project, they find that they have to reinvent the wheel. They can't get access or find past work to be able to, say, fork it and accelerate production. They basically just have to start from scratch. And along with that comes, it's just really hard to collaborate with some of their peers to really get projects done faster. The people who manage these teams just find it hard to be able to track all of the, the work that's being done inside the organization and set projects and set goals and track the progress and just be able to manage their teams more effectively. And then the third area is around getting models into production. We hear all the time about organizations that take months or full quarters to get models into production. And even once they get them into production, they find that, they're not in a format that the business stakeholders are able to use to make critical business decisions. And they find that they're having to spend a ton of time from a data scientist perspective actively monitoring the models and make sure that they remain accurate. When you think about all of the challenges that I just talked about, the one common theme is that data science work and infrastructure is not centralized. And that is really the objective that we're solving with Domino. It really starts at a very basic level with the workbench. This is where the data scientists are going to go to do all their R&D work. They'll have access to on-demand compute resources, and they can spin up different sorts of workspaces, be it Jupyter or RStudio or a number of different things. And this is the place that they're going to do all of their experimentation, run, track, compare experiments, and really do their work to pick the best model. That works hand in hand with our model ops capabilities, where once you've identified a model, this is where you'll be able to put them into production through a REST API that you can call from an application, or build out an app that a business stakeholder could use to interact with the underlying model. And it's also the place that you'll go to look at all of the models that are in production and then analyze their performance. Underpinning all of this is a set of scalable enterprise infrastructure that allows you to orchestrate compute, be it CPU, GPU, Spark. You'll be able to set up data connections so you'll have access to all of the information that you need for experimentation. It manages all the packages. So, languages and new environments and all the updates and all the things that slow down data science work can all be orchestrated directly through, scalable package and environment management. And in today's environment, it runs on any infrastructure. So it can be on cloud, it can be on the on-prem, be a variety of different places. And then finally, sitting at the top of the stack, if you will, is what we call a knowledge center. So this is where data scientists can go to find, reuse, reproduce past work and get started on projects a lot quicker. It's also the place that data science leaders can go to manage their teams, establish consistent standards and best practices, set goals for projects, track their progress, identify any sort of blockers that their team is running into. And it's also the place that an IT team could go so that they can look and see who's using resources, how they're being used, what the costs are, and just overall manage their IT resources that are being deployed. Okay, so let's jump into Domino 4.2, which, as I said, became available about 2 weeks ago. The features that we're rolling out and the things that we're going to talk about really fall into three main buckets. So in a second, Yorgi's going to talk about the things that we're doing from an open infrastructure perspective. As I mentioned, as a system of record, it's important to have an open infrastructure that allows new capabilities to be easily integrated into the platform. And he's going to talk about some of the things we're doing from new Kubernetes distributions that are available inside the product, our ability to export a completed model into production on Amazon SageMaker, and then also be able to spin up Spark clusters on demand for scalable experimentation. Then Austin is going to talk about some of the things we're doing from a collaborative R&D perspective, and specifically the data science project management capabilities that we're adding for data science leaders, as well as the ability to integrate Git repositories into Domino. And then I'll be back to talk about a brand new product that we've introduced called Domino Model Monitor, which will allow you to monitor the models that you have in production to make sure that they're always remaining accurate and allow you to make the best predictions possible. Okay, so with that, I'm going to hand it off to Yorgi, who's going to talk about our open infrastructure.
Thanks, Bob. All right, let me quickly switch our screen share. As Bob mentioned, I'll cover some of the new capabilities related to our open infrastructure. And as we think through those, it makes sense to quickly look at the evolution of the Domino approach to openness. Like traditionally, Domino has always been a system that doesn't necessarily provide proprietary data science algorithms and tools, and we've always had the opinion that data scientists know best, and they have preferences, and they are able to bring the tools that make sense for them to the platform. And that's what we did at first. Like any tool that is containerizable, any language that could be made available has always been part of the core value proposition of Domino. Over the last 12 months, we have started evolving this initial approach a little bit. First came our ability to break out of specific walled gardens of different cloud providers and really make sure that Domino is available on any infrastructure. Some of that was powered by our transition to Kubernetes as an orchestrator for everything that we do, but it really gave us a nice way of making sure that Domino is available anywhere where our customers need it, whether that's in popular cloud providers or on-prem. And now that we sort of completed this transition to a much more powerful orchestrator, we're really setting our sights on kind of next level of openness, which at least the way we think about it comes in the form of enabling various distributed compute frameworks directly on top of Domino's infrastructure. As you see a little bit later, we're starting with Spark as the first framework here. But the intent is really to continue this and introduce other popular frameworks as well, with the eventual goal of making this pluggable the same way we have done this for tools in the past, so that organizations that have different preferences can really react quickly to what is a rapidly changing environment and a flourishing open source ecosystem with respect to the various frameworks that are available. This always is really consistent with our philosophy that in everything we do, we want to preserve the choice that data scientists have. Make sure that they don't get locked into a particular framework, be it a proprietary framework or an open source framework. And for us, this really is a key part of making sure that Domino remains a future-proof platform, where as data science evolve, the platform is flexible enough to support folks. The first element of this vision that we realized in Domino Force 2 is really a continuation of what we've done in the past few releases. As we completed the transition to Kubernetes, we've been working our way through certified support for popular Kubernetes distributions. In the past, we've had support for Rancher as a way of forming on-prem and cloud clusters. We had support for the managed offerings by AWS and Google Cloud. And with Domino 4.2, we're pleased to add support for the Microsoft managed offering, which is AKS on Microsoft Azure, as well as VMware PKS, which is just recently got rebranded as Tanzu Kubernetes Grid. And just as a bit of a preview of what's to come, the team is hard at work in terms of enabling OpenShift as sort of a on-prem platform of choice for a number of folks in the enterprise. Again, one of our key philosophies is preserving freedom of choice, and we do this not just in terms of infrastructure, but also in terms of how we think about productionizing data science work. Domino has had the ability to host models and applications on the platform itself for a long time. But we also realize that a number of our customers have different types of requirements for their production systems. And they oftentimes want to deploy work developed on Domino elsewhere. In Domino 4.1 previously, we introduced a more generic way of exporting models created on Domino through a CI/CD pipeline, deploying them on any platform that is capable of running containers. And we're continuing on this with Domino 4.2, where we have adapted this capability specifically to Amazon SageMaker as a kind of scalable model hosting platform, where now folks would have the ability, again, through their CI/CD pipeline, to export models in a format that is immediately suitable for running on SageMaker without any modification. The last big part of our journey towards open infrastructure is the new OnDemand Spark capability that we're adding to Domino. It has been clear for us for some time that the power of Domino comes from being able to do different types of workloads on the platform and really use the right tools for the job. And that's really how we think of Spark. We don't really think of Domino as a platform that would enable someone to really only focus on Spark, but it's a great platform where you can use Spark for the workloads that make sense, and then be able to also use right tools in a way that is more natural for everything else. Be able to do both at the same time. And just a little bit about kind of what we're adding here and how it relates to some of our capabilities from the past. Again, Domino has had for a long time the ability to for data scientists to create to external Spark cluster that might be managed by IT or might be provisioned in a different system. And that has been a powerful capability, but it usually created a ton of friction around how these clusters get provisioned, how all of this gets configured. We've gotten a ton of feedback that our customers really appreciate the way Domino already orchestrates infrastructure for them. And there was clear demand for being able to get the Spark paradigm directly onto the infrastructure that we manage. And this is what on-demand Spark clusters on Domino are. Spark gets deployed in containerized form directly on the Kubernetes infrastructure that Domino manages. That is done on demand for data scientists as they start their workspaces and jobs. And to get into it a little bit more, the way we think about what really changes for folks here is it becomes very, very easy to do all of this. I'm going to go into a demo here in a second, but you would see that as a data scientist, you only need to think about a handful of parameters when deciding that you want to connect your workspace to a Spark cluster that you're going to use for a Spark application. right? All of that fits very nicely with how we already manage environments in Domino. You'll have the ability to do this and manage dependencies and packages that need to be deployed on these Spark clusters, very much the same way that this is done in Domino today. For IT folks who operate the Domino platform, it would relieve some of the pressure that they feel today in terms of managing separate Spark clusters, to the extent that some of the use cases that their data scientists use are suitable for Domino OnDemand Spark cluster. There are a number of kind of nice features that are built into how we orchestrate these clusters on demand that we also think will let them realize some significant cost savings. The lifecycle of these clusters is automatically bound to the lifecycle of Workspace and jobs in Domino, so they only come and go as they're needed, as opposed to sort of being permanent fixtures of the IT landscape. And last but not least, again, it's sort of consistent with our overall vision for Domino. We're bringing the choice to have Spark workloads alongside of other workloads that you're already utilizing Domino for. Take advantage of our reproducibility and other capabilities as interacting with Spark and as you're using it appropriately. And just a little bit to cover use cases that we think are particularly good fit for OnDemand Spark on Domino. Essentially, all of the kind of data science flavored workflow workloads that Spark supports today. Distributed machine learning, we're orchestrating Apache Spark, a vanilla version on Domino, so everything that's available through MOlib becomes immediately available for folks. Through enhancing their Spark environments, they can certainly enable other distributed compute frameworks that run on top of Spark as well. Exploratory analysis, one of the key strengths of Spark is the ability to load a large amount of data efficiently, and being able to do exploratory interactive analysis through Spark SQL. We're going to see that in a second. And last but not least, featureization and transformation work on aggregated data sets, right? Tasks around relabeling, aggregation, sampling of data sets become a little bit more natural for folks who are familiar with what Spark is a paradigm, and now they have the ability to do this alongside the rest of the work that they might be doing on Domino. So with that, let's actually jump into a demo and see what this looks like in our environment. Let me just stop the cluster that I already have. And one of the things that I just covered is the ease of use that we have in terms of launching one of these clusters, right? So first thing you would see, we'll launch a Spark cluster alongside a Domino workspace. You still have the same experience today that you have today when creating a workspace. Some of this dialogue is actually new, and Austin is going to go into some of the improvements we've made to the overall workspaces interface. But when you choose the hardware tier here, you're really also choosing the resources that are going to be available to your Spark driver. You can choose an appropriately enabled environment that has PySpark in this case. And then really I get to select the parameters of my Spark application that I'm going to be running alongside of this workspace. I can select the number of executors that are going to be available when I connect to the Spark cluster. And for each of them, in a very kind of domino-esque way, I can specify the amount of resources that should be available as part of each of these executors, as well as I can specify the amount of resources available to the Spark master. And last but not least, you have a set of environments that are specifically designated as Spark-enabled environments. Those are the ones that you're going to use to distribute various dependencies and packages that need to be available to your cluster. And you can also specify the amount of dedicated storage that will be available for each of these executors, and this is storage that is used for Spark shuffle jobs and RDDs that don't fit in memory. So we have flexibility there. So let's actually go and start this. And what Domino is doing right now is, in addition to starting the workspace, it's also in parallel, it's deploying a Spark cluster with the requested parameters on this infrastructure. It handles all of the networking between that Spark cluster and the workspace that is being created, so that it'll be very easy for the data scientists to just initiate their session with Spark and get going. So I'll open one of my notebooks that I have here, and I'll demonstrate how easy it is to actually connect to the cluster that we created. So what we've done as part of setting this, a lot of the defaults of the Spark configuration that are needed to be able to connect to the cluster itself are already set in the context of this workspace. So when I go in, just create default context, it already connects the cluster in my workspace appropriately. Like, so the Spark master that is dynamically orchestrated on Kubernetes, it's properly set in the environment. The connection back to the workspace as the driver is appropriately set. All of my settings around the executors in terms of the memory that I requested, all of that is now available. And instead of calculating pi or anything that is very common in these Spark demos, we're actually going to go and access some data that people have in their environments already. In this case, we're demonstrating accessing some data from S3. So I'm just going to go and load up a quick table here. And we can see it's basically a simple collection of people and their age. I can very easily then transition into Spark SQL, where I can do like SQL style queries against this data, in which case maybe I'm interested in which of these users are above the legal drinking age. So I can execute a quick statement here and I get a response back. So it's obviously just a demo and works with much larger data sets, allows you to load that up in memory and do interactive analysis. One of the other things that I quickly want to highlight is the way you manage environments in Spark. This is a big part of how you can distribute dependencies, which is typically a challenge for shared Spark clusters. Now that's completely integrated with how we do environment management in Domino. Now for some of the environments that you're going to be creating, they're going to be designated as Domino managed Spark environments, where you can truly install additional packages that may need to be available. In this case, I'm adding like NumPy, as well as adding the dependencies that are needed to be able to access S3 data from my Spark environment. And then the best part is, I forgot to mention, is in addition to just integrating it really nicely with a Domino workspace, we're also giving full access in an integrated way to the Spark Web UI, which is a powerful way that data scientists can use to troubleshoot their Spark jobs if they run into any problems. And the best part is when I go and stop my workspace, I don't have to think about how needing to clean up my cluster. That would automatically get deprovisioned for me as part of the lifecycle of the workspace. All right, that's pretty much it.
Cool, thanks, Yorgi. While Austin's getting set up, you had mentioned what OnDemand Spark would be good for.
Mm-hmm.
Are there any things that it's not good for in this case? Yeah,
the ephemeral nature of these clusters means that they kind of come and go. So there are a few use cases that at this point are probably not a great fit, right? So while Spark itself supports like streaming applications, they usually require like long-running clusters to be available. So not a good fit there. Any of the use cases that require collocation of Hadoop data and the compute, like if you notice what I did in the demo, the data was located at an external data source, which would either be S3 or Domino data sets or other cloud provider storage. But anything that is sort of traditional Hadoop and Spark co-location would not be necessarily a good fit. And the last one I want to caution against maybe is like very intensive like ETL jobs that are kind of have real-time type requirements. Again, those are usually better served by dedicated clusters that are able to process the data as it comes.
Cool. Very good. Thanks, Yorgi. If you want to go ahead and just pass control over to Austin, or just take it. And
go ahead.
We'll jump into the collaborative R&D section.
All right. Thanks, Bob and Yorgi. As Bob mentioned, I'm going to be talking a little bit about our collaborative R&D features that are coming as part of 4.2, and also a little bit that came as part of earlier 4.x releases. So this includes the new features that we have introduced to make data science project management native in Domino, and also our new and improved Git repository integration. So starting with the first part, data science project management. As Bob said sort of at the start, one of the real challenges of data science is managing data science at scale. Getting visibility into the status of all of the different data science projects that are happening at your company, understanding what kind of business value is being delivered and ensuring that your data scientists are focused on delivering that business value, and so on. And so as part of our effort to provide the sort of one-stop shop for data science, we want to be sure that we are bringing these capabilities that enable you to manage your data science function, data science practice into Domino. So among these things are our introduction of stages for data science projects in Domino. So data science stages are ways of marking where in the process of data science product development your projects are. They could be anything like ideation or the acquisition and exploration of data, all the way to deploying a given product to production, or putting it into monitoring, something where you may want to monitor the success or the performance of a given model, for instance, in production. So we've enabled a standard set of stages, but you can bring these stages that make sense to your project and your data science practice into Domino. We have also enabled you to set the different specific goals for your projects in Domino. So these can be explicit tasks that your data scientists need to do in order to meet success criteria for the project that they are working on, Or they could be literal success metrics for models if you want to make sure that the performance is beating an existing model in production, or so on. Sort of whatever markers of success you feel are right for your data science projects. We've also enabled you to, or data scientists to attach the evidence that shows that they have met these goals into the goals, and so that you can see them at a glance. Another feature is the ability for data scientists to mark when they are blocked inside of a project. It may be that they have encountered a problem that they don't know how to solve, or a dependency in another part of the organization that they need help resolving before they can make progress. And so they can flag their project as blocked in a way that allows you to be able to see this at a glance and intervene as necessary. Now, the new part of the project management suite that we have introduced in the 4.2 release is an integration with Atlassian's Jira project management software. So Jira is the sort of enterprise standard for project management. And since many companies use Jira already for project management, or many data science functions may feel pressured from other parts of the organization to bring their project management into Jira, we wanted to be able to support that natively in Domino. And so what we've done is link the goal and stage functionality explicitly to workflows in Jira, so that you have a one-stop shop for managing your data science projects. You don't have to worry about going back and forth between Jira and Domino. You can do it all in one place inside of Domino, and then the resulting changes will be reflected in Jira for anyone that needs to access them or consume them there. One of the ways that we've enabled you to actually see all of this is through our project portfolio, which is sort of visible here. And this is exactly that surface that gives you the one-stop shop, or the bird's eye view of all the different projects that are happening in your data science deployment. It allows you to see the relative goal completion, what stages these projects are at, if they're blocked or if they're not blocked, how active they are, and so on. So why is this exciting? Well, this allows you to not only align your data science practice, or your data science team, with sort of the best practices that exist in data science, through actually explicitly identifying these goals, connecting the work that your data scientists are doing to the business value that they are delivering. But it also allows you to sort of explicitly connect the artifacts that data scientists are producing to this business value and to the sort of markers of success for your projects. It also elevates the visibility and transparency and the ability for your data scientists to collaborate. Since we want Domino to be this data science system of record, we also want it to be the sort of system of record for all of the projects in your organization and the management of those projects. It gives you the one place to view status, and it gives you that way to unblock your data scientists so that they can continue to provide business value and deliver the products that your business needs. And by bringing in Jira, we are now integrating with your existing workflows. So if you already use Jira, like I said, we now can simply integrate directly with what you were doing before, and then reflect that inside of Domino. So the second thing that I want to talk about is the new Git repo integration, which is currently in preview, launching with 4.2. So today in Domino, we manage version control through our own Domino file system, or DFS. DFS automatically versions everything that your data scientists work on when they complete a batch job or when they finish running an interactive workspace. They don't have to worry about sort of the managing the versions of their files. Domino sort of takes care of it for them. However, it is increasingly common, and we know that sort of Git is becoming more the standard for version control in data science, much like it has become the standard for version control in software engineering. And so there's often a lot of push from so IT organizations to have data scientists also keep their files in the standard Git repository used by the other functions of a business. And so with 4.2, we are bringing in the beginnings of our integration to make externally hosted Git code repositories the sort of home for code in Domino projects. So you can now use your existing Git repos as the primary way of housing project files, and you can use the corresponding features like pull requests inside of GitHub to do the management of sort of merging and progress through the evolution of your code and your data science products. So let's jump right into a demo. And I want to show off both of these features, both the data science project management features and the new Git integration together. So I'm going to quickly exit out of this presentation. Okay, and so what I'm looking at right now is a project that is actually backed by Git in Domino. So this is a project called Flightily. It's just a silly dummy project that I'm going to use to walk you through a few of these features. And so what you'll notice is one, that there's a new navigation here on the left-hand side. This is a navigation that we're sort of exploring and playing with as part of introducing Git-backed projects. In particular, if I go here and I click on code, you can see that the code here is linked to a particular Git repository in GitHub. And if I click on this link, it'll actually bring me to the code that is in that code repository on GitHub. Similarly, you can see that we've sort of segmented up some of the links that exist in the current Domino navigation by their functions. And at the top here, I'll bring your attention to where you can see the stage that this project is in. The stage is currently in the R&D stage, and here I would have the ability to designate if I'm blocked, if I run into some sort of problem, or also I can designate that I've completed the project. Now, if I go back to the overview page here, if I were the data science manager for this project and I wanted to actually manage this or link the management of this project to my existing project management workflow in Jira, I have the ability to do that through linking a Jira ticket here. So if I switch here to Jira, I actually have a Jira ticket that I'm going to use as the Jira ticket which backs the management of this project. So this is DPT 14, and so when I want to link this Jira ticket, all I have to do is click on that button, and it brings up this dialog, and I just search for the ticket that I'm looking for. And so here is DPT 14, and Domino will automatically load in the ticket, the description that's in the ticket, so you can see whatever has been described as part of the Jira ticket, and also any subtasks that might have existed for that ticket. And when I link this ticket to my project, you'll see that the Jira ticket appears here. I can analyze flight delay data, which is the sort of primary thrust of, or at least the conceit for this project, as well as those two subtasks now appear as goals for this project. And you can also see the stage and status of these goals, this project and these goals here on the right. And so this project stage is currently in model development. And so you'll see now that I've linked this ticket, it's actually reflected in the stage of the project up in the top left. And then these goals are in independent validation and approval for use. And so the stages and the status that appear here are going to reflect the workflow that exists in your Jira project. At this point, I want to sort of run through a quick little Git workflow based on the conceit of this flight delay data project. So what I'm going to do is I'm going to launch a workspace and go in and actually look at the work that's been done in this project. Here you can see a sort of redesigned quick action flow. I've clicked on the quick action in the top left, and this allows me to then launch a workspace or a job. And so I'm going to choose to launch a workspace. And here you'll see the new redesigned workspace start flow that is coming as part of 4.2. And so with 4.2, we wanted to introduce the ability for you to choose your environment and your hardware tier on demand for the workspace. And so you can configure your individual workspace as needed on demand. I'm going to choose the small hardware tier here. If I choose a different environment, for instance, this MATLAB environment, it actually reflects the workspaces or the IDEs, excuse me, that are part of the environment right when I select it. So I can choose a environment that's appropriate for the work I want to do, that has the tool that I want in it, and then access that tool immediately. And then further down, I'd be able to add Domino data sets to this, or I can add the Spark clusters you saw before. So I'm just going to go ahead and launch this workspace. And then I'm going to jump into a workspace that I actually already have running so that we don't have to wait for it to spin up. So this is the new in-workspace experience. And I want to say just a few words about this before going through the Git flow. In 4.2, we had a real focus on improving the user experience of data scientists using workspaces to do their work. And so we overhauled the entire, what we called the Chrome, or this sort of outer part of the experience, so that everything a data scientist would need when they're working in a workspace is available to them. So on the left here, you'll see the new file changes panel, which includes not only changes to code, and since this is a Git-backed project, it's actually got that link to the Git repo that exists in GitHub, and this will pick up any changes that you might make to your code. It also has a way for you to use the existing Domino file system to capture things that are really big, like model binaries or CSV blobs and so on, that you don't necessarily want to check into your code repo. There's a panel here for the workspace settings. This includes your environment and your hardware, and it would also show any attached data sets or the Spark cluster configuration information that you might have if you attached one of the on-demand Spark clusters to this workspace. I can view the resource usage of my workspace. This includes both the CPU and the memory, and you can see that I haven't used very much of either so far. And then finally, you can access the logs for this workspace. And then along the top, you can see the name of the workspace. You can see the name of the Git repo being used. And then I have ways of saving and pushing my work out to the Git repo. I have the ability to stop and access back to the workspaces list in the regular Domino interface. Then at the top right, I can see my tool. And I'm currently using JupyterLab. Okay, so jumping into this project, I'm going to just quickly run through the execution of this notebook. I've loaded in some data, and you can see here that it's flight delay data. It has information about flights from 1987. And I'm going to sort of work with the conceit that I want to understand information about these flights. So there are many, many different columns here. And as I said, it exists in, these are all flights from 1987. And so I'm going to pose a really sort of simple and silly question, which is, what's the average distance flown out of San Francisco on Mondays by carrier in this year? And so I can do that pretty easily. I'm just going to sort of manipulate the data down so that I only get the columns that I need. I'm going to restrict that to just Mondays, and then I can compute the averages sort of straight away using basic pandas techniques. And so as part of this, I'm going to just overwrite this because it doesn't matter. As part of sort of looking at this work, I might say to myself, okay, this looks good as the person sort of reviewing this work. But what it really might need is a graph, because I don't want to look at a table. It'd be much easier to see just a graph. And so what I'm going to actually do is I'm going to use the command line to check out a new branch, which I'm going to call add a plot. And so what this does is it switches me to a new branch in my sort of local Git repository. And then I can go back here and I can say, okay, I think this needs a plot. So I'm going to actually just plot the results in this bar graph. And then I'm going to say, okay, this looks good. But what I want to do is actually also export this plot to, also going to get it right. I'm going to export this as an image. And so here you can see that I actually have created a new plot, which is this PNG, and it is exported out to my Git repo. And so I'm going to hit save and go back here to my command line and check this into the branch. So I hit git status. I can see that I've modified my notebook, and I've also exported this PNG. So what I'm going to do is I'm going to add both of these. And you can see that they're added here. And now I want to commit them into my repo. And so this is now committed in. And I might say I could create a pull request and go through sort of a GitHub flow. And let's say that I did that. Or maybe I want to just sort of entirely skip it. And just to sort of demonstrate this functionality, I can actually merge my changes back in at the command line. So I'm going to say I want to merge the changes I made on that branch back into master. I've checked out master, and I want to merge in the branch that I had just made, which is add a plot. And so I can do this really easily. I haven't made any sort of significant changes that create merge conflicts. And so now I have actually added that commit into the history of the master branch. And now finally, I just want to push. And so I'm going to push this out to GitHub so that it persists to my remote repository. And voila. And so if I go back to this Git repo, we see that I've committed the commit has made it to GitHub. Oops. Wrong window. And that's the basic Git functionality for 4.2. So I can stop this workspace. Voila. And so I might go back then as the sort of manager or the person reviewing this and look at my sort of goal here, and I might say that it looks great. I added a plot. I can hit save. This creates a comment, and then I could go and say that this is approved for use, just using one of my stages. And then if I go back here to the actual Jira ticket, I refresh. I see that that has changed. And the comment that I added actually is finished. It appears in Jira. Okay. And that's it.
That's awesome. I love that. If you want to pass over to me, and Austin, I got a question for you. You had mentioned that the Git integration is in preview right now. If somebody wanted to try that out, what would they do?
Absolutely. So the Git integration ships with 4.2. It is hidden behind a feature flag. So if you want to enable a specific user or all your users to have access to the ability to create projects that are backed by Git, all you have to do is flip that feature flag for the user or for the group of users that you want to give this kind of access to.
Cool. All right. Good stuff. All right, let me take it on home from here. I'm going to cut my section a little bit short so we make sure we have some time for Q&A. So we introduced a brand new product called Domino Model Monitor a few weeks ago. And basically it's designed to solve a problem that many companies face, whereas models degrade over time. And that might be because, there's macro data that's changing, whether it's the price of oil or the stock market. I mean, everything is constantly in flux, and that may change some of the inputs into a particular model. Customer preferences may change. If you think about models built using data from 2019, here we are in the middle of a pandemic. You really have to ask yourself, are those models even relevant today? And then you may have industrial sensors that are feeding data into a model. And, as those things start to, wear down or even break and environmental conditions go on, how do you identify when you need to go either replace the sensor or replace a model, right? You may also have broken data pipelines where, your model was expecting a certain range of values and all of a sudden it was getting null values and making some really bad decisions. So at a high level, we've introduced this brand new product called Domino Model Monitor. And what it will do is it will take and compare production data that's happening in real time and compare it to data that was used to train the model, and then run statistical checks to see have the input features or any specific input feature changed. How is the output predictions being compared to the training data? You can feed in actual information in the form of ground truth to look at performance drift and see, did it predict something was going to be a yes and it actually turned out to be a no. You can also automate a lot of the monitoring so that instead of your data scientists having to constantly be watching models, they can go about their their day job, and they'll get a proactive alert that says, hey, we got a model here that you might want to take a look at, and then they can drill in and figure out, is it a broken data pipeline? Does it need to be rebuilt or retrained, et cetera? And also, it applies a consistent approach to monitoring for all models across the organization. So you don't have one department doing it one way, another department doing it a different way, and maybe a third department not doing it at all. Here's the one place you can go to see all models in production and see how they're performing. Shameless plug here, Samit and I, a colleague of mine, we're going to be doing a webinar on July 14th. We're going to do a lot more detail about why models degrade, what you can do about it, and we're going to run through a demo of Domino Model Monitor. So if you're interested in this topic, absolutely, I would encourage you all to sign up for the webinar, and it's going to be really, really good. So with that, that's Domino 4.2. Let me jump into, I want to try to wrap this up in the next couple of minutes. We had a couple of questions that had come in. First question, and I'll throw this one over to Jorgi. Will hybrid deployments become available soon? That is having compute resources, that is having compute resources across both on-premise and in the cloud, managed under a single Domino deployment.
Yeah, it's a great question and a timely one. As some of our on-prem customers are starting to move assets to the cloud, this particular use case is becoming more important. As we're completing sort of the transition and support for the major Kubernetes distributions, this is sort of the next frontier where we're starting to look. Those of you who are Domino customers currently will likely get an invitation to join that particular conversation with actually me and our CTO are leading that particular effort. We're starting to do initial architecture sessions and validation with folks who have expressed interest in this specifically.
Cool. One more question for you, Yorgi. Does 4.2 have the capability to monitor GPU usage?
If I understand the question correctly, it is around the same way we do show CPU usage, being able to see GPU usage for a particular workspace. I don't believe we've added that.
Okay. Okay. Another question, do customers automatically get Domino 4.2 or do they have to pay for an upgrade? All the capabilities that you saw demonstrated by Yorgi and by Austin are part of our release. So if you're an existing customer, you can upgrade to 4.2 and get all of those included as part of your subscription. Domino Model Monitor is a separate product, licensed separately, purchased separately. So you would have to subscribe for DMM separately of Domino. Okay. Let's see. I think that's probably it at the top of the hour. If there are any other questions that came in, we'll go ahead and address them offline. But I just wanted to give a quick set of information about where you can go and get more information. Obviously on our website, there's all of the web pages have been updated to include Domino 4.2 information. We put out a press release a few weeks ago, a couple of blogs about the 4.2 features in general, as well as one on DMM specifically that you can find on our website. And that's it. So again, thank you so much for joining us today. You'll get more information after the website. The team will follow up with you, give you the ability to get the recording, pass it on to some of your colleagues. And again, thank you all for joining us today. We really do appreciate it. And have a good rest of your day.